Okay, I will need to take off within in couple minutes. Very likely I come back after 1 hour, but with only half an hour left later on, I don't think you want to stay. So let me, this is what I did in the last basically 40 minutes or 15 minutes. I did some problem, mainly multiple of 4, number 4, 8, and then 12, and then 14, and then 18. This number 18 is quite long, and then number 20. I try to do with two methods, traditional and tabular method. Okay, what I will do is I will save this now and I will post it on our discussion board. Okay, at least up to this number 20. And then then I will leave you for a while. I hope only 1 hour, and then come back in 1 hour. I'm so sorry. If you don't want to stay, I don't blame you. I will record it anyway later on. Okay. This uncle is someone quite crucial for my family. That's why I don't want to be not attending, at least show some gesture of condolences to his family. And I mean, it is a sincere one though, because like what I said, at least that's what I do. Okay, show my face. Okay, but this family is it's a big family, but they have been very crucial for my family. I can share with you that when my dad had cancer in 1982, this is actually their family, not in particular this uncle, but this family, including his siblings, were the one who support my family financially a lot when my dad had that cancer. And then in 2003, my brother was diagnosed with the same cancer with my dad, and this family again came out and helped us financially. Now, at that time, I did my PhD, and the reason I stopped my PhD is because of my dad had cancer and need a lot of money. I didn't feel I didn't feel that I should continue with my PhD study while my brother needs so much money for his treatment at that time. So I took 1 year off from my PhD study, and it turns out that toward the end of that 1 month, 1 year, you call that pause of my PhD study, I get hired at West LA College. That's why I never went back to my PhD study. Okay, but yes, this family has been critical for my family. Like the thing is, like when they have that the funeral, actually 2 days ago, when they had that funeral, I didn't attend because I was sick. During this weekend, I was really sick. So I feel bad if I don't even attend this one, you know. If I attended that one, then I would have been okay if I don't attend this one. Okay, so I will post it there. Please read this. Please read. And after I'm done with the procession, if they are done earlier, then I will come back here. Okay. But if they are not done in 1 hour, then I'll still log off and then come back here. But when I come back here, if you are not here, I'm totally fine with that. On Wednesday, then I will continue on the second part of 7.1. And I think at that time, I need to boost up faster with all the way to 7.3. So please continue watching the lecture video. Okay, even I have not done, I believe what I did in the lectures already enough for you to start working on problems on the suggested homework. But then when I come back, when we come back on Wednesday, you already have questions to ask me. Okay, but again, I will come back later on in 1 hour. I will come back in 1 hour. I will leave the meeting, but I will not end it. I will leave the meeting. So you guys can discuss, ask one another if you have questions. And when I come back again, you can ask me questions. I will. Who wants to be the host?
I don't know about that, but my condolences, Thomas, and thank you for still doing what you do for this class.
Okay.
I appreciate it.
Thank you. Who should be? Let me assign Itzel. Is it okay, Itzel? Where's Itzel? Let me assign Itzel to be the host. Okay. Okay, 7.1a is something I already posted. Then I will continue with 7.1b. Okay, let me know if you have any question. Because if not, then I will just continue. Okay, I did number 20 earlier. Let me do number 22. Number 22, integral of arc sine x being squared dx. If you feel comfortable using traditional method, go ahead. I think you should be comfortable with that. But I strongly recommend you to learn how to use the tabular method. Okay? I will do the left-hand side, the derivative. So derivative of arc sine x squared will be 2 sine inverse x times 1 over square root of 1 minus x squared, while the one here is just x. Okay, so this becomes x times sine inverse x being squared minus 2 times integral of x over square root of 1 minus x squared sine inverse x dx. Now the thing is, we cannot integrate sine inverse x. We can, but it's more complicated. So what I will do is I will rewrite this part here. You will see that I basically rewrite this part here to be the following. So I will do the derivative of sine inverse x, and I move the rest to the right. Okay, so the part that I circled there is the same to what I have here. As you can see on the right hand side, that's basically doing this massage. Okay, minus integral of sine inverse x times 2x over square root of 1 minus x squared dx. Now, how do we know that I need to do derivative of sine inverse x instead of integrating it? Well, because we cannot integrate that easily, we can differentiate that easily. Okay, so from there I go on. The derivative of sine inverse x is 1 over square root of 1 minus x squared. Now, on the other hand, the integral of what we have on the right-hand side is actually negative 1 over square root of 1 minus x squared. So in other words, then we get x times sine inverse x being squared minus bracket, okay, negative sine inverse x over square root of 1 minus x squared. Okay, remember the product here, the positive product, and therefore this is the negative integral of the negative product. So there will be minus integral of negative 1 over 1 minus x squared dx. How do we integrate that? I suddenly don't know how to integrate that without using partial fraction decomposition. Well, anyway, this is x times sine inverse x squared plus sine inverse x over square root of 1 minus x squared minus integral of 1 over 1 minus x being squared dx. Do I make any mistake somewhere? I mean, it's not that I don't know how to integrate this. Not that I don't know that. What I know is this requires integration, partial fraction decomposition that we will see in 7.4, I think. Not right now. Is it 7.4? Yeah, that's 7.4. Unless I do anything wrong, I don't think so. Now I see my mistake. No, this is wrong. This integral is wrong. I did it incorrectly. Supposed to be negative square root of 1 minus x squared. Duh, I make it so much harder than supposed to. So this is actually minus just negative 1. So this is plus integral of dx, that's x plus constant. Okay, so that's the integral. Okay, but this is important one. So the first one is positive product. Okay, the next one is the alternate sign. That's why I have this negative here, and then this negative comes here. Okay, it's alternating. That's for this number 22. Then we go on with number 24. This time we have definite integral. Integral from 0 to 1 of x squared plus 1 times e to the negative x. How do we know which one to differentiate and which one to integrate? If you have polynomial, then you know that's the one you differentiate because it will eventually go down to 0. The e to the negative x is easy to integrate. So I will do the differentiation here. And the one here I keep on integrating. do the alternating. So positive product, negative product, positive product. So this is equal to negative x squared plus 1 times e to the negative x minus the blue one, it's negative product, right? Minus 2x e to the negative x. And then the yellow one is the positive product, minus 2 e to the negative x plus constant. Okay. Actually, no. That's a definite integral. So that will be from 0 to 1. Then when x equals to 1, what happened? When x equals to 1, that will be negative 2e to the negative 1 minus 2e to the negative 1 minus 2e to the negative 1 minus when x equals to 0, it's negative 1 minus 0 minus 2. This is negative 6 over e plus 3. So 3 minus 6 over e. Unless I make some miscomputation, but I don't think so. Okay, somehow I think our textbook will write it this way, or the solution will write it this way instead. So either way is fine. Basically, they do LCD for that number 24. Number 26. Number 26, integral from 4 to 9 of ln y, ln y, yeah, that's right, over square root of y dy. Let me rewrite it this way, integral from 4 to 9 of natural log of y times 1 over square root of y dy. Then the derivative of ln y is 1 over y. The integral of y to the negative 1/2 is square root of y times 2, I believe. Okay, now the thing is, pay attention that, well, the first one is this positive product, right? Now the thing is, I will do horizontally here instead of keep on going. Okay, the derivative of 1 over y will never keep going down to 0. No, it will be negative 2, negative 3, negative 4 exponent, right? So instead of going that way, I go horizontally, especially because I know I can simplify this product. Okay, so this becomes 2 square root of y natural log of y minus integral of 2 square root of y over y dy. I will simplify. 2 square root of y natural log of y minus 2 over square root of y dy. That will be, I think that will be positive 4 y to the power of 1/2 or negative. Negative, I'm sorry. That's negative 4 square root of y plus, oh, hold on. Oh, I have definite integral. Why I keep on forgetting that? Yeah, good thing I look back. So now I put that definite integral here. So this is from 4 to 9. This is 4 to 9. This is 4 to 9. This is 4 to 9. But this is from 4 to 9. Now I plug in numbers. 2 square root of 9 ln 9 minus 4 square root of 9 minus, when y is 4, and complete further, I have 6 ln 9 minus 12 minus 4 ln 4 plus 8. So I get 6 natural log of 9 minus 4 natural log of 4 minus 4. That's for number 26. Number 28. Definite integral from 0 to 2 pi of t squared sine 2t dt. There will be 2t to 0 integral sinus negative cosine. Keep on integrating. So this integral becomes negative t squared over 2 cosine 2t. Let me color that first. So the positive product, negative product, positive product. Okay. Now, if you try to do it with traditional method, then it actually means you need to do integration by parts 3 times. Now, the good thing about this tabular method is instead of doing all the formality u, d, phi, du thingy, okay, we just summarize everything into this table. Now, then go on with the result. So the blue one is negative product. That becomes plus t over 2 sine 2t plus 1/4 cosine 2t, but all of them from 0 to 2 pi. So this will be negative 4 pi squared over 2 cosine 4 pi is 1 plus 2 pi over 2 sine 2 pi, oh that's 0, plus 1/4 cosine 4 pi is 1 minus 0 plus 0 plus 1/4. So the 1/4 cancel, we end up with negative 2 pi squared. Okay, that's for number 28. Before I go on, I need to emphasize this, which I believe I already emphasized in my lecture. The following. One big use of integration by parts is to enable us to integrate a function which we can't integrate or it can't integrate originally but can differentiate. A couple classic examples are, for example, integral of tangent inverse x dx. That's a very classic integral application of integration by parts. Why? Because we don't know how to integrate tangent inverse. That's the question here. What is the integral of tangent inverse? No, but we know the derivative of tangent inverse. So we can do it this way. The derivative of tangent inverse is 1 over 1 plus x squared. Integral of dx, or just 1 dx, is x. From here, we get this is the positive product minus horizontal, so negative integral of the product. X tangent inverse x minus integral of x over 1 plus x squared dx. Now, the thing is, The second part there is integrable by substitution. Okay, so let u equals to 1 plus x squared. So du will be 2x dx, right? So this is integral of 1 over u times du over 2. As minus 1/2 natural log of absolute u plus constant, which will give us x tangent inverse of x minus 1/2 natural log of 1 plus x squared plus constant. Now I take off the absolute sign because 1 plus x squared is always positive anyway. So this is if we go horizontally, no integral, I'm sorry, if we go diagonally, no integral sign. If we go horizontally, we have integral sign. Okay. Now, another example, classic example of this this point of view is, well, then can you find the integral of, for example, sine inverse x? Again, the question here is what is the integral sine inverse x? But to do it, we do integration by parts instead. So you need to memorize the derivative of sine inverse x, tangent inverse x, and secant inverse x. Okay, so this becomes x sine inverse x, that's for the diagonal product, okay, minus the horizontal product. So I have integral sign x over square root of 1 minus x squared dx. But again, if my u equals to 1 minus x squared, my du therefore negative 2x dx. Then it becomes x sine inverse x plus 1/2 integral du over square root of u. Now, the integral of that will be, let me change the color again, x sine inverse x plus square root of u plus constant, where the square root of u is square root of 1 minus x squared plus constant. Another one is integral of natural log. Okay, but this one is actually on the easy side. The derivative of natural log of x is 1 over x. The integral of dx is x. So the diagonal product, that's x ln x minus, I'm sorry, yeah, diagonal product minus horizontal product, we have integral sign. So 1 over x times x dx, which is just 1. So this will be x natural log of x minus x plus 1. Let me see, I have a message coming in. Is the integral of, in what happened to 1/2 in the integral of inverse sine? What happened to 1/2 in the integral of inverse sine? The one here? The one here? The thing is the integral of 1/2 1 over 2 radical u is radical u. In other words, u to the power of 1/2, when you do the derivative, you will get 1/2 times 1 over radical u. You see, so the integral of that 1/2 1 over 2 radical u is radical u itself. Okay, maybe I say it this way. The integral of this, the whole thing here, will give us this. Does it make sense? Okay. So keep this in mind though. Keep this in mind, because to be honest with you, I did ask this kind of question even to people with master's degree, and they don't know what to do. This simple one, they don't know what to do. Like, I even give the hint, do integration by parts, and they still don't know what to do. To my surprise. Okay, now let me continue with, I did number 28, let me go on with number 30. Integration by part is being used a lot and heavily in differential equation, and knowing this tabular method will save your time by big time. I have heard cases where my students from my calculus 2, they went to differential equation with Dr. Awash, and they could do the integrals, let's say in 1 or 2 minutes, but the rest of the class, who was not from my class, they took like 10 minutes and they still get it wrong. Okay, so the superiority of this tabular method becomes very clear when you go to differential equation. Now, differential equation, to solve a differential equation, we integrate. Right? To undo an operation, you do the inverse operation, right? Okay. That's why then your integration skill needs to be super strong when you go to differential equation. Now let's take a look on this one here. Again, I don't know the integral of tangent inverse, so I do the derivative instead. I will get 1 over 1 plus 1 over x squared times the chain rule. And this is x. So I will get x tangent inverse 1 over x. Oh, that's a definite integral. Let me put this in. Okay. Then minus the horizontal product. So I need to use integral. But I have negative in there. Let me change that to positive right away. Or maybe not. I do it later. So 1 square root of 3. Okay. Negative 1 over x squared times 1 over 1 plus 1 over x being squared times x dx. Is it okay? I don't simplify anything yet. I just basically multiply them. Then on the first term, I will compute that later at the same time. So let me just leave it like this. While on the right-hand side, the second term, I will simplify. Okay, I will simplify. That becomes integral from 1 square root of 3. I will multiply this x squared on the denominator and distribute that here. Okay, so I will get x over 1 plus x squared dx. Okay, now big warning though, once you use u substitution, if your integral variable of integration becomes u, then the limit of integration should also change in terms of u. You cannot change this into du, but this still in terms of x. No, that's a violation. You can't do that. Okay, I know what you mean, but that's not what you write. Okay, I saw that in some students, some of your quiz, I didn't finish your quiz 1, 2 yet, but for those that I already finished, I saw that. And that's not right though. Yes, your calculus 1 teacher may allow that, but I also mentioned before, you should not do that. Okay, you should not do that. Again, if your the numbers that you have here represent the value of the variable you use here. So that's why we don't need to write x equals anymore. We don't need to, because we already know if the variable is x, then these numbers represent x. Okay, that's the rule. That's the rule. I mean, I understand what you mean, but still, you still need to say it right once you use mathematical notation. Okay, you cannot invent your own notation. Okay, if you can invent your own notation, then I will invent it first before you. Okay, no, it's just no. Even Thomas cannot do that though. I wish I can do that, but no, it's not. Okay, now, in other words, suppose from there you use U substitution. Okay, U equals to 1 plus x squared, such that your du is 2x dx. Then you need to change your limit of integration right away. Okay, so this becomes x tangent inverse of 1 over x from 1 to radical 3 plus integral from 2 to 4 of 1 over u times du over 2. Okay, that's the right way to do it. Okay, after you integrate, if you want to put it back in terms of x, fine, even though I don't see the purpose. It's just like after you're done with your x, you already substitute that person. Why do you want to go back to your x? You already break up. Okay, so when x equals to radical 3, so this is radical 3 times tangent inverse of 1 over, that's pi over 6 minus pi over 4 plus 1/2 ln 4 over 2. So this will be pi radical 3 over 6 minus pi over 4 plus 1/2 natural log of 2. Now you see that the work gets more and more tedious. Okay, so organize your work. Do not detach your work. Don't detach, don't detach. In other words, I know you may want to just work on this one, right? You see, that's what you keep on doing, right? But I still copy this part. I still copy this part, even though I don't do anything with that. Yes, that's a waste of time. You know, you may say it that way, but I have seen cases where people lose track of their own work. Okay? And they say, oh, you know what, that's just little mistake. No, that's not little mistake. You set you set yourself up for mistakes if you detach the work. Especially if you don't organize your work, right? Then it gets more complicated later on for yourself. It's like if you don't organize your work, even easy problems becomes hard. Okay, I go to a more difficult question. I think number 34. I think this is more difficult, but I don't know. Integral from 1 to 2, natural log of x squared over x cubed dx. Natural log of x, I don't know how to integrate. Let me rewrite it to natural log of x being squared times x to the power of negative 3 dx. So that on the left hand side I differentiate, on the right hand side I integrate. So this is 2 natural log of x times 1 over x. The one on the right hand side, that's 1/2 x to the negative 2. Now notice that we will have this later on, this guy, okay, minus the integral of this. But if you notice, what we have here is that this x to the negative 1 over x here, can go to the right hand side. Okay, so let me do it this way instead. So the one in blue can be rewritten as natural log of x on the left hand side, and this guy go to the right. I get x to the -3. Then I do integration by parts again. Okay, so this becomes 1 over x. This becomes 1/2 x to the power of -2. So this is our first product. This becomes our second product. This becomes our third product. Okay, so this is equal to 1/2. You know what? Maybe I write it this way. Natural log of x being squared times 1 over 2x squared from 1 to 2 minus 1/2 natural log of x over x squared plus integral 1/2 x to the -3 dx. And this one also. So this will be natural log of x being squared over 2x squared minus natural log of x over 2x squared, all of them from 1 to 2 plus, what is the integral here? That's minus 1/4 x to the power of -3 from 1 to 2. Then we plug in numbers. Natural log of 2 being squared over 8 minus natural log of 2 over 8 minus, when it's 1, that's 0 minus 0, minus 1/4 times 1/4 minus 1. Minus 1 over 16. Okay, so what happened here? I think we deserve some more explanation here. The integral 2 ln x times 1 over x times 1/2 x to the power of -2, I rearrange them. Basically, the 1/2 cancel, ln x stays on the left hand side, okay, and then x to the -3 stays on the right hand side. Then from there, I continue doing integration by part. That's for number 34. The one requiring substitution, number 38, integral t cubed minus times e to the -t squared dt. I don't like this guy. So let's call that u for now. U equals to t squared, so du is 2t dt. Oh, then I need extra t to help. This is integral t squared e to the -t squared times t dt. Notice how I rewrite this t cubed becomes t squared times t. Let me use another color. The t cubed here, I rewrite that as t squared times t. What is the purpose? Because when I substitute u equals to t squared, the derivative has that t dt. And so I need that here. I need that here. Now substitution, I will get becomes integral u squared. No, not u squared, just u. U e to the negative u du over 2, which is 1/2 integral u times e to the negative u du. Then from here we do integration by parts. 1, 0, this is negative e to the negative u, e to the negative u. So this is equals to 1/2 times negative u e to the negative u, the positive product, and then the negative product here, minus e to the negative u plus constant. Or we can simplify that to be negative u plus 1 over 2 e to the u plus constant. I factor the negative out, and also e to the negative u out and put it at the bottom. Oh, I'm not done yet. I'm sorry. I'm supposed to bring it back to t. My bad. So this will be negative of 1 plus t squared over 2e to the t squared plus constant. Number 42. Looks so innocent. Integral of sine natural log of x dx. It looks very innocent until you start using substitution. So u equals to ln x. So du equals to 1 over x dx. Okay, but x du equals to dx. What is x? From here, e to the u equals to x. That's what I need to substitute there. E to the u du equals to dx. Then I bring it in. This is integral sine u times e to the u du. Neither one of these functions, sine function or e to the u function, if we differentiate, eventually goes down to 0. Neither one of them like that. If you see this case, then you know you need to do some flipping in the middle. Let's call this I. And on the right hand side, I will do integration by parts. Derivative of sine u is cosine u. Derivative of cosine u is negative sine u. And the integral here is e to the u, e to the u. So I equals to the positive product and negative product. And then later on, we have positive product here. That's sine u e to the u minus cosine u e to the u minus integral of sine u e to the u du. But this guy is just I, right? So I bring it to the left hand side. 2i becomes sine u e to the u minus cosine u e to the u plus a constant. Then divide by 2, I get the integral that I need. Oh, I'm using the 1/2 here. Divide by 2, then that's a new constant. Finally, integral of, what's that? Original integral sine u, sine ln x dx, which is our I, is now becomes 1/2 sine ln x times x. We'll put the x here. minus 1/2 cosine ln x times x, that's why I put x here, plus constant. Okay, this is where I will stop for now. You should be able to try to work up to number 41. You should be able to do up to number 41. Now on Wednesday, I will continue a bit more from this section here. Focus on sum reduction formula. I think I will do 1 or 2 of them. Okay, but please review important integral. One of the important integral that you need to memorize is integral of secant cube x dx, especially. Why? Because we see this a lot. Okay, because we see this a lot in later section, so memorize better. Okay, again, I'm sorry for what happened today. Well, first they told me that it will start at 7:30, but then when they told me start at 7:30, the person who announced it was not aware with the difference of time, how to say that, the time zone in Indonesia. We have 3 different time zones, and they thought that the time that person used is the Jakarta's time zone, while my hometown is 1 hour later. Is it 1 hour later or 1 hour earlier? Basically, then that kind of miscommunication make me thought that we start at 7:30 LA time. It turns out that it's not only my misunderstanding, it's basically the announcement misunderstanding. So when I joined at 7:30, we have like 300 people there waiting for the Zoom, but then they found out that it's actually wrong timing, wrong time zone, just like the one we have here, like East Coast, West Coast time zone thingy. Yeah, but my hometown start time is the same to Taipei and Bangkok. But the person who set the time with Jakarta, which is 1 hour difference. Yeah, that's what happened earlier. Anyway, I will stop here again. On Wednesday, I will continue with 7.1c, just a little bit more, and then 7.2, 7.3. But I hope you can ask me questions so that I don't need to do do too many problems unnecessarily. Okay, see you then on Wednesday.
Thank you.